Hi, everybody. Today is Friday, February 2nd. So today we will continue to work on session 7.5. And then next Monday, you're going to have homework 2 about 7.2 and 7.3. Okay? And you also have quiz 1. So quiz 1 will be about 7.1, 7.2, and 7.3. Okay? And you remember the quiz is in Blackboard, no, not Blackboard, Canvas. So go to Canvas quizzes and then your deadline is different than mine. Okay, but I would say still try to finish your quiz early. And remember that if you get locked out because your internet is not stable or you need a little bit more time, feel free to start a second attempt right away and then submit your answer. But if you use more than one attempt, just kind of email me and just let me know. Okay, everybody? Yes. So that is your quiz. Let's see. Okay, yes. So homework 2 and quiz is on Monday. All right. So let's continue on session 7.5. Area between curves. So last time we talked about to compute the area between two functions, like the Riemann sum. We cut it into so many rectangles. So the area is sum of the area of the rectangles. For each rectangle, the width is dx. The height is f of x minus g of x. That's why we get the formula. Integral x goes from a to b. The height is f of x minus g of x. The width is the dx. And last time we did example 1. We draw the function. Remember our map depth? Yes. So if you kind of forgot what the shape is the function, it's okay. You can always draw the table. Okay, plug in some x values to find the y values, and then plug those on the xy plane. Connect them smoothly. Hopefully, you can see the region and your x. See this example, x goes from -1 to 0. The upper function. Do you see the upper function is the x-axis? That's the horizontal line, y equals 0, constant function, right? And minus this, the lower function is x cubed. The last time we integrate, so x to the 4 over 4, we plug in 0 first, minus, we plug in -1. But -1, don't forget parentheses. So it becomes positive 1/4. Okay, y is positive. Isn't it the area is under the x-axis? Should the area be negative? No. Because why? What are we doing? We're looking for the area between the curves. So in the definition, we use the upper curve minus the lower curve. So this guy is always positive. Right? Yeah, in this case, you see x cubed is negative, but we minus x cubed, it make it positive. That's why our area is positive. Okay, so yeah, if the problem asks you to find the area between the two curves, your area should always be positive. If you get a negative area, maybe your upper function and lower function flip. So just go back and change the minus sign. Okay. And example 2. Okay, let's continue. Example 2. We draw the picture. Kind of figure out what the graph look like. So we have two functions, e to the 7x and the fifth root of x. X goes from 0 to 1. Okay, that's x, that's the y. And let's see, x, 0, 1. Look at the y. Here, e to the 7 times 0 is 0. What's e to the 0? 1, right? If we plug in 1, it's e to the 7. Okay, I know at 0 is 1. And then 1, I know it's going to be a big function. So, sorry. Let's put e to the 7 here. Okay, and then let's connect those 2 points. Okay. So exponential function looks like this. Right? I know e to the 7 is so big number, but you don't want to put so big. Let's just put here, e to the 7 right here. We just want to sketch the graph. And the other function, fifth root of x. That's x to the what power? 1/5. Yes. If we plug in 0, what happened? What's 0 to the 1/5? 0. Yeah, 0, right? Yep. And what is 1 to the 1/5? Is 1, right? 1 to the whatever power is 1. So at 0 is 0. At 1 is 1. And do you remember like square root or cube root? The shape is like that, right? Yes, curved down a little bit. So when we draw the picture, we know it curved like this. Yes, it curved like this. Okay, so we sketch the picture. And then it says find the area of the region bounded by those two curves, and x is 0 and x equals to 1. So we're looking for this region. So area is integral. X goes from where to where? X is from where to where? 0 to 1. And then we use the upper function. Who's the upper function? Yes. So upper function, y equals e to the 7x. So e to the 7x minus the lower function. Who's the lower function? Yeah, the fifth root of x. Let's put x to the 1/5 because the next step we're gonna integrate them, right? We want to get the standard form, then we integrate. What is integral of e to the 7x? 7e to the 7x, or in the denominator. Yeah? When we take the derivative, we multiply by 7. When we take the antiderivative, we divide it by 7. Is that okay, everybody? How about x to the 1/5? What do we do to the exponent? Add 1. Then it becomes 6/5. And then we over the new exponents. But what do you do to the 5? Flip it up there. Yes, everybody? So we put the 5, flip it up there. Okay, so it's 5 over 6 times x to the 6 over 5. Now evaluate from 0 to 1. Okay, let's see. We plug in 1. We plug in 1, we get 1 over 7. E to the 7 times 1 is 7. Minus 5 over 6. And when we plug in x is 1, 1 to the whatever power is 1. We just get that. So this is what happens when we plug in 1. Subtract when we plug in 0. When we plug in 0, this is 1 over 7 e to the 7 times 0 is 0. And minus, okay, I see an x when I plug in 0. This term is 0. But what is e to the 0? 1. Oh, so we get 1 over 7 e to the 7 minus 5 over 6, and then minus 1 over 7. Is that okay, everybody? Mm-hmm. You can leave your answer like that, or you can put this in your calculator and get maybe 4 decimal places. Mm-hmm. Yeah, we can also combine them. So this one is like negative, and then 6, 7. What's the common denominator? 42, right? And then the 5 you multiply by 7 is 35. But because you factor out a negative, then this becomes plus, right? And here, what do you put here? 6. Yes. So we get what? Negative 41 over 42. Oh, because 1 to the whatever power is 1. 1 squared is 1. 1 square root of 1 is 1. Big root of 1 is 1. 1 to the whatever power is 1. It's kind of like a lot of properties of 1 over 1. Okay, that is example 2. Yes. Oh, because it's minus. So you put the minus in front, then it's like a parenthesis. And the middle sign here becomes plus. Yeah, so okay. So it's like minus and 5 over 6 plus 1 over 7. So when you combine them.
Yeah, because you're distributing.
Yeah, exactly.
Negative 1.
The negative 1 distributes. Right. That's why I hope, I'm afraid that when you try to simplify, you make some mistake. Maybe just put this in your calculator and give me one that makes this. Yeah. Okay, good. So example 2. Example 3. Find the area of the region bounded by those two graphs. Okay, so this problem is harder because like the previous problem, it tells us the x is from 0 to 1, right? But this problem, it does not tell us what the x and what the start from where to where. We have to figure out the intersection points. Okay, so let's draw the picture and then we can have some idea what is going on. X squared minus 2x. What is the shape of the graph? Parabola, like that. Yes? And okay, can you see here we can factor out the x? What's left? Yes. So we know the x-intercepts is 0 and 2. Yes, everybody? That's the x-intercepts. And let's plug in 1. What happened? If we plug in 1, we get what? 1 squared minus 2 is negative 1. So we plug in 1, we get negative 1. So this is a parabola like that. And then we have the second graph. What's this? Right? This is the slope intercept. Yes, slope is the coefficient. The y-intercept. Yes, everybody? So we have the y-intercept is 1, 2, 3, 4 here. And then the slope is 1. So it's a line like that. And we want to figure out the intersection. We want to find the region bounded by those two graphs. Then we need to figure out the intersection. So we need to find the intersection points. Okay. So one way is keep plotting the points. Okay, one way to plot the points. And I can tell you for most of the function I asked you, the intersection points will be integer points. Okay, so you keep plotting the points until you can find it. For example, like this. Okay, if I go to the left, if I plug in -1, what happened? -1 squared minus 2 times -1 is? What is -1 squared? 1. And then plus 2 is 3. Oh, you see? -1, 3 is right here. Let's check the y. I mean the line. We have the x and we have the y. So when x is -1, look at the y. -1 plus 4. What happened? That's 3. Yes? See? We find this intersection point is really -1 and 3. So the method 1 is you plot point and then you find it. Okay, and of course make the table to verify it's really the point on both of the curve. Okay, how about the other one? Let's try 3. If we plug in 3, what happened? 3 squared minus 2 times 3. What's 3 squared? 9. 2 times 3, 6, which is 3. Okay, 3, 3, right here. Is that an intersection point? No, right? It's right here. Let's continue. Next number is what? 4. 4 squared minus 2 times 4. What's 4 squared? 2 times 4, 8. 16 minus 8 is 8. Okay, so 4, 8, right there. How about the line? If we plug in x as 4, what happened? 4 plus 4 is... Oh, you see? Just by plotting points, we can find the intersection. Is that okay, everybody? So this is method 1, plot the points. And I can tell you most of the example I asked you, the intersection point are integer points. That's why you can find them just plotting in integers. How about second way? Okay, second way is more general. Second way is to set up a system of equation. So, and this is the more general way. So your intersection may be not integers, and then this set up the system this way is more general. Okay, so you have the two system, y equals x squared minus 2x, and y equals x plus 4. You learn how to solve system of linear equations. You have substitution and elimination methods, right? So in this case, this is a nonlinear system. We use substitution. So you see your y is x plus 4, and put in the first equation. You get x plus 4 equals x squared minus 2x. And, well, how do you solve polynomial equations? Move all the terms on one side. So we can subtract x, subtract 4, subtract 4. Then we have x squared. How many x? Minus how many x? 3x. And minus 4 equals 0. So far, so good. And now, what do we do? Okay, we can factor them. That's x, that's x. What do we put right here? Yes, minus 4 plus 1. So x minus 4 is 0, or x plus 1 is 0. X is what? 4, or x is negative 1. And then you can plug in your y here. If x is 4, the y is what? We can plug in here or here, but plugging the line is easier. Do you agree? 4 plus 4 is 8. And if x is minus 1, what's the y? 3. Yeah, we plug in here, minus 1 plus 4 is 3. So this is how to find the intersection point in general. Okay? But the difficulty is you need to solve the system of equations. In this case, this is just a quadratic and this is linear, so it's still easy to solve. But what if I give you a degree 4 polynomial? Can you solve the degree 4 polynomial? We don't have a fixed method to solve that. Okay? Or if I give you something weird like exponential function or like square root, cube root, then it's hard to solve the system. Then in that case, I suggest you to plot points. Okay, so all the intersection points, I would say most of the problems, the intersection points are integer points. So keep putting in the point, then you can see it. Okay, now, good. We find the intersection point. Then we can find the area. That's the area. Okay, x goes from where to where? Negative 1 to 4. Who's the upper function? X plus 4. The line is the upper function. Who is the lower function? X squared minus 2x. And make sure you put, let me see, parentheses around them. This is so important. Because if we forget the parentheses, our answer will be wrong. The upper function minus the lower function. Parentheses. Okay? Let's simplify them first. Okay, so it's x plus 4. Distribute the negative, so it becomes what? Negative x squared, and then plus 2x. Good. Okay, so before we calculate, let's combine the like terms. How about let's reorder it from the highest power to the lowest power? Who's the highest power? Yeah, so negative, right? X squared. And then how many x? 3x. The constant is 4. Okay, so we combine them. And we're ready to integrate. Okay, let's see. What's integral of negative x squared? What's the integral of negative x squared? What do you do to the exponents? Yeah, we add 1, so it's x third over 3. Yes. Plus 3x. So 3 constant multiple stays here. What's integral of x? Yeah, x squared over 2. And what happened to the 4? 4 times x. Good. We evaluate from -1 to 4. So far, so good? Okay, we plug in 4. So we have -4 cubed over 3 plus 3 times, what is 4 squared? 16 over 2, right? Plus 4 times 4? 16. And 16 over 2, we cancel. What's left? 8. Yes. Minus, we plug in -1. And make sure you put the parentheses first. Okay? When you subtract, make sure you put the parentheses. We plug in -1. What's -1 cubed? -1. Oh, but there's a -1 in front of that. Plus 1. Yeah, so we get 1/3. And what's -1 squared? 1. So this is 3/2. Oh yeah. And then we plug in -1. It becomes -4. Yes, everybody? So put this in your calculator. What did you get? This is your calculator. What did you get? Can your calculator give you fractions? If you have if it's fraction, then put in fraction. You get that answer instead of one. So what do you get? 125 over 6. Yes, so the answer is 125 over 6. Okay, everybody? So in the exams, you can give me fractions, you can give me decimals. So usually if you put decimal, put 4 decimal places. Okay? So this is example 3. It does not tell us whether x star and n. We need to find the intersection point. I teach you 2 methods to find the intersection point. Either keep plotting in the points until you find it, or set up the system of equation. Okay, let's continue. Example 4. Find the area bounded by y equals square root of x plus 3 and y equals x plus 3 over 2. So let's do that. Okay, let's see. Draw this. Okay, so when we try to sketch the graph, plot integer points. Okay, think about it. So this x and y, square root of x plus 3, plot integer points. What is the smallest x you can do? What is the smallest x? Smallest.
-2.
negative 2. Can it be like even smaller?
No.
Can it be negative 3? Negative 3?
Oh yeah, that's right, because it could be 0.
Yeah,
Okay,
yeah. Remember the square root function? It starts with 0 and then goes like that. And then you think about what is the smallest x possible? Well, the smallest is when x plus 3 is 0. So x is negative 3. Negative 3 is smallest. If you plug in negative 3, what do you get? 0. Yeah, so negative 3, we get 0. That's x, that's y. Okay, and then next, we want to put integer points. The next number of x, we can get integer. Negative 2, very good. If we plug in negative 2, what happened? Yeah, we get square root of 1, which is 1. See, negative 2, we get 1. Right, everybody? Then how about the next integer? It will be 1. Right, everybody? Because negative 1 doesn't work, 0 doesn't work. But when we plug in 1, we get square root of, what is 1 plus 3? 4. Square root of 4 is 2. See, 1 is right here. And we have 2. Okay. Who's the next integer point? So 2 work. 6. Yes, everybody? We plug in 6. What is 6 plus 3? 9. Square root of 9 is 3, right? So we plot integer point. 1, 2, 3, 4, 5, 6. And we're at 3 right there. And then we connect the points smoothly. This is the square root y equals square root of x plus 3. Plot integer points. Okay. Now, the second function is a linear function, right? Then you know it's a line. Also, we want to plot integer point. So give me some x value so you get integer. 3. Yes. We can plug in 3. Then what do you get? 3 plus 3 over 2 is 3. Okay. And how many points can fix a line? 2 points. Okay, so give me one more point. 1. We plug in 1, what happened? Yeah, 1 plus 3 over 2 is 4 over 2, which is 2. So 3, 3 right there. And 1, 2 right there. And we connect them. Hey, when we connect them, do you see it looks like it passed through the point minus 3, 0, right? Let's verify that. We plug in x is negative 3. What happened to your y? Is 0. Yay! See, by plugging in the points, we draw the graph and we find the intersection is negative 3, 0 and 1, 2. Okay, everybody? So this is what I mean by plotting in the points. Okay, just put some integer points, then you can see the intersection. So you don't need to solve the system of equations. You know, it takes time. It's square roots. Yeah, it takes time to solve it. Okay. Now we want to find the area between them. So area, x goes from where to where? Negative 3 to 1, yes. Who's the upper function? the square root of x plus 3. Who's the lower function? Yes. All right. So we want to integrate that. Okay.
How do we pick -3 to 1?
Oh,
The integration of -3 to 1.
so here, the intersection point.
Oh, okay. Yeah,
Yeah.
that makes sense. Yeah.
Right. So we want to integrate them. Remember, we only be able to integrate 3 types of functions. First type is x to the n, right? Second type, exponential function e to the ax. The third type, the 1 over x integral 1 over x and f to the x. And this is power function, but not exactly x to the some power. In this case, we need
Exponent.
this is like composite function, right?
Oh, U substitution.
Yeah, U substitution. Yes. Oh, we can break them apart. This part use U substitution. This one is just a power function, so we can integrate the right parts. Yes. So let's break them. Okay, so we have -3 to 1 and square root of x plus 3 dx. And minus, can I put the 1/2 in front? Then I have x plus 3 dx. So I separate up. The integral I separate up. And the second one, I put the 1/2 in front of it. Is that okay, everybody? This is where we take care of that later. Let's figure out this part. Okay, so this part is -1/2. What is integral of x? Integral of x cubed, x squared over 2. Integral of 3x. And we evaluate from -3 to 1. So that equals -1/2. And then we plug in 1. We plug in 1 first. So if we plug in 1, what happens? 1/2 plus 3. But then minus, okay, you gotta be careful if you put minus. You need a parenthesis. What is -3 squared? 9. Good. Yes, the minus square become positive. So 9 over 2. And then what is 3 times -3? -9. Yes, so -9 right here. Okay, so this is -1/2. 1/2 plus 3. Let's distribute the negative. It become what? -1/9 and then plus 9. Okay, let's see. What is 1/2 minus 9/2? -8/2, which is -4. Right, everybody? -4. What is 3 plus 9? 12 minus 4? 8. Yes, everybody? This is 8. So we get -1/2 times 8, which is -4. Yes. So this part is -4. Now let's take care of these parts. Need U substitution. Okay. So U substitution. Let's use orange color. What is the U? What's the inner function? X plus 3. What's the U? Dx. Then this equals U of negative 3, U of 1, and then the square root of U dx is du. Is that okay, everybody? Remember, this is a definite integral, and U substitution, there are two ways. You either change the x values to U values, and you plug in the U, or you keep the x values, and then but you have to get the x back. You plug in the x. Which way did you prefer? The second way, the change back to x and plug in the x values? Mm-hmm. Yes? Do you still remember? Mm-hmm. Okay. So yeah, the second, let's integrate that. So we have U of negative 3, U of 1. Square root of U is U to the what power? 1/2 du. So U of negative 3 and U of 1. Now we're ready to integrate. What is the integral of U to the 1/2? Yes. 3 plus 1. 3 over 2. Yes. Over 3 over 2. But what do you do to the 2? Bring it up. So we have 2 upstairs. Now we evaluate from U of negative 3 and U of 1. We need to get the x back. What is U? X plus 3 to the 3/2. Now, see, we get the x back. So now it's from negative 3 to 1. Is that okay, everybody? Yeah. So we plug in 1 first. So 2 over 3. We plug in 1. We get 1 plus 3 to the 3/2. Bless you. Yes, everybody? Minus, we plug in negative 3. So plug in negative 3. Oh, let's see. Let's wait until everybody gets to this step. So far, so good? Okay. Now we calculate. What is 1 plus 3? 4. What is square root of 4? 2. What's 2 cubed? Good. So this is 8. Yeah? This is 8. And now, so 2 times 8 is what? 16 over 3. And the second one, what is negative 3 plus 3? 0. So the whole thing is 0. Yeah, everybody? So our final answer. So come back. Our final answer. Well, or you can just say area is this part, which is 16 over 3. And then this part is minus 4. Bless you. Okay. Common denominator is 3. 4 is what over 3? 12. 16 minus 12 is 4. So the answer is 4 over 3. Okay, everybody? Yes. Okay, let me see. So this is example 4. Any questions about example 4? No? Okay. So again, first step, we want to sketch the graph. Okay? And we want to plot integer points. And then hopefully you can find the intersection point as well. Now you can set up the integral, the x goes from where to where, use the upper function minus the lower function. And in this process, 3 types of integral we have learned. Power rule, exponential function, one over x. If it's not one of them, that means we need to do more stuff. So break the integral. Okay? This part, use substitution. This part, we can confuse. And then at the end, we find the answer together. Okay, everybody? So, yeah, let's finish early today. And work on your homework. Monday, we have the homework due and your quiz one. Yeah? Right. Are you able to open the 7 to 10? Let me see. So, okay.